Exercise 10B, question number 1 A. So we need to find the force, resultant force. We'll work out the resultant vector. So minus I plus 3j plus 4I minus j. So this is going to be minus 1 plus 4I plus 3 plus 3 minus 1 j. This is 3I plus 2j Newton. And 5 3 plus minus 3 minus 6. So 5 plus 3, 3 minus 6. So 8 minus 2. So 5 minus 3, 3 minus 6. So this is 5 minus 3, 2 minus 3. And part C, resultant vector is I plus j plus 5I minus 3j plus minus 2I minus j. So I plus j plus 5I minus 3j minus 2I minus j. So this is going to be 6I 1 plus 5 minus 2I plus 1 minus 2 minus 3 minus 1 j. So this is going to be 4I minus 3j. R is minus 1 4 plus 6 0 minus 2 minus 7. So this is going to be minus 1 plus 6 minus 2, 4 plus 0 minus 7. So this is going to be 3 minus 3 Newton. Question number 2. An object is in equilibrium under action of F1, F2, F3, and AR is F1 plus F2 plus F3. So R1 equal F1 is 2I plus 7j plus F2 minus 3I plus j, and F3 minus I plus j plus F3 R. R equals 0 because it's given that as object is in equilibrium, hence minus I plus 8j plus F3 equals 0. F3 equal I minus 8j. Next one, part B. R equal 3I minus 4j plus 2I minus 3j plus f3. So r equal 3 plus 2i plus minus 4 plus 3j. So this is 5i minus j plus f3r. As r equals 0, 5i minus j plus f3 equal 0. So f3 equal minus 5i plus j. Question number 3, that forces in equilibrium, we need to find A and B. R equal A plus 2B, AI plus 2BJ plus minus 2AI plus minus BJ plus 3I minus 4J equal A minus 2A plus 3I plus 2B minus B minus 4J. So this is minus A plus 3I plus B minus 4J. R equals 0 as object is in equilibrium. Hence minus A plus 3I plus B minus 4J equal 0I plus 0J. So minus A plus 3 equals 0, B minus 4 equals 0, A equal 3, and B equal 4 Newton. Question number 4, we need to find the magnitude and the angle. So A equal 3I plus 4J. This is the particle. 3I act on here. 4J act on here. Then as a result, it move into this direction. So we'll find, let's say this is theta, and since this is rectangular, this is 4J, this is also 4J. And let's consider this is resultant force is R. So R is mod R is 3 square plus 4 square root. So this is the magnitude, that is going to be the square root 25 equal 5 Newton, and tan theta equal, this is if we come and stand up here, this is right 90 degrees, opposite divided by adjacent, so 4 divided by 3, theta equal tan inverse 4 divided by 3. So this is 53.1. Five I minus j. So this is 5I, and this is j minus j. So this is the resultant force R. If this is there, this is a rectangular. This is because of that. This is also minus j. This is, let's we'll consider theta. So mod r is, now we can find pi square plus minus 1 square root, which is square root 26, and tan theta equal the 1 divided by 5. Theta equal tan inverse 1/5, that is 11.3 with I. This is the particle. So this is minus 2I, and this is 3J. So particle is moving on this direction. So if this is 3J, this is 3J. Let's consider this is alpha. And R equal minus 2 square plus 3 square root. This is 4 plus 9 square root 13. And tan alpha is 3 divided by 2. Alpha equal tan inverse 3 divided by 2, which is 56.3. So this is 56.3, and we'll write as a bearing. This is 135. This is 180. Let's say this is beta. Beta is 180 minus 56, 123.7. So plus, this is 123 plus another 90. We write as a bearing, plus 90. That is this 313.7 with I. So if you measure for this direction, beta is with I, it is minus 123.7 if you measure this way. If you measure the positively, so this is going to be 360 minus that. D is minus I minus J. So this is the particle, and this is minus I, and this is minus J. So it's going to be this direction. This is R. Magnitude of R is minus 1 square plus minus 1 square root 2 Newton. And tan theta, if I take this is theta, is 1 over 1, and that is going to be 1. Theta equal tan inverse 1 is 45. So this is 45, and this is 45. And you can write this one as with I positive direction, 180 minus 45. So this is going to be 225. I with a negative direction, 135, 180 minus 45. If you measure from here, Question number 5. We need to find the resultant vector and magnitude of the resultant vector and the bearing. So this is 5 question E1. R is minus 2I plus J plus 5I plus 2J plus minus I minus 4J and minus 2 plus 5 minus 1I plus 1 plus 2 minus 4J. So this is going to be 2I minus J. And magnitude is mod R is 2 square plus minus 1 square root 5 Newton. So we need the direction now. 2I and this is J minus J. So we'll take this as theta. So theta equal 1 over 2 tan theta. Theta equal tan inverse half. So tan inverse half is 26.6. So we need bearings. So this angle is 26. Bearing mean we have to calculate from north. Part 3 is 90 plus. So this is 90 and this 26.6. So this is going to be 116.6. So this is minus 2I plus J plus 2I minus 3J plus 3I plus 6J. So R equal minus 2 plus 2 plus 3I plus J. So this is going to be 3I plus 4J Newton. So question number 2, magnitude of R is 3 square 4 square root 9 plus 16, that is 25, which is going to be 5 Newton. So which direction? So 3I 4J, this is 3I, this is 4J. Now I need the bearing, this one. So this is 3I, this is also 3I, this is 4I. So I will take this as beta. So tan beta equal 3 over 4. Beta equal tan inverse 3 over 4. That is going to be 36.9. If you find this angle, then you have to take 190 minus this one. So I straight calculate from this one beta. So bearing is 36.9. If you calculate these are theta like this, tan theta equal 4 over 3, then theta equal tan inverse 4 over 3, then this is going to be 53.1. Then to get this one, so this is 53.1. To get this one, 90 minus 53.1, which is 36.9. The forces are in equilibrium, so AI minus BG plus bi minus plus aj plus minus 4i minus 2j. So this is equal a plus b minus 4i plus minus b plus a minus 2j. R equals 0 as object is in equilibrium. So then a plus b minus 4 equals 0 minus b plus a minus 2 equals 0. So a plus b equal 4 minus b plus a equal minus 2 positive 2. This is 1 and 2. When you add 1 plus 2, the answer is going to be 2a equals 6, a equal 3. Then from 2, from 1, b equal 4 minus a, which is 4 minus 3, 1. So this is 1 and this is 3 and this is 1. Number 7, that is also same type of sum. So r t-a-y 2ay plus 2bj plus minus 5bi plus 3aj plus minus 11i minus 7j. So this is 2a minus 5b minus 11i plus 2b plus 3a minus 7j. R equals 0 as object is in equilibrium. Hence 2a minus 5b minus 11 times I equal 2b plus 3a minus 7j equal 0i plus 0j. By considering the I component, 2a minus 5b minus 10 equals 0, and this one 2b plus 3a, then j component 2b plus 3a minus 7 equal 0. So from here we can get 2a minus 5b equal 10. This is from here 2b plus 3a equals 7. This is 1 and 2. I can see this is 5b. This is 2b. I am going to make this one to 10 and add. So 1 multiplied by 2, then this is become minus 10. Add, then 2 multiplied by add. So this is 10 and it is cancelled out. So then this is going to be 4a minus 10b plus 10b plus 15a equal, this is 22 plus this is 35. This is cancelled out. 19a equal 57, a equal 57 divided by 19 is 3. Now a value is 3. I need to find b. From 2, 2b equals 7, 3a, 2b equals 7 times 3, 3. So 2b equal 7 minus 9 minus 2, b equal minus 1. So this is 3 Newton and minus 1 Newton. Actually it is, we'll stay without the 3 and minus 1. Question 8, part A. Three forces in equilibrium, so R equal minus 3I plus 7J, so R equal F1 plus F2 plus F3. So this is going to be F2 I minus J, and then Pi minus plus Qj. So R equal minus 3 plus 1 plus Pi plus this is 7. 7 minus 1 plus Qj, which is minus 2 plus Pi plus 6 plus Qj. R equals 0 as object is in equilibrium. Hence, minus 2 plus Pi plus 6 plus Qj equals 0 I plus 0j. When you consider I component, so minus 2 plus P equals 0, P equal 2. When you consider J component, so 6 plus Q equals 0, Q equal minus 6. Part B, the resultant force of F1 and F2 is R. Calculate the magnitude. So R equal minus 3I plus 7J plus so R equal F1 plus F2. So this is I minus J. So R equal minus 3 plus 1I plus 7 minus 1 J. This is minus 2I plus 6J. So magnitude is mod R is minus 2 square plus 6 square root 4 plus 36 root square root 46.32 Newton, and the magnitude angle, so minus 2I, if this is the particle, so this is minus 2I and then 6J. So this is the particle actually, for two forces is working on, this is 6J. So I'll consider this one. So this is R. So R equal, so R we found out. We need the bearing between the line of action R and the vector G. So this is, we need beta. So then this is going to be minus 2I to this direction. This is tan beta equal 2 over 6, which is 1 over third. So beta equal tan inverse 1 over third, 14.43, approximately 40. Question number 9. F1 is given 3I minus 2J. F2 is given AI plus 2AJ. Question A, we need to find the angle between F2 and I. So F2, this is AI, and this is going to be 2AJ. This is on the particle. So we'll work out, so this is the direction. of that f2. So this is 2aj for this day. This is theta. So we need to find the angle between this one, INF2. So this is INF2. So tan theta equal 2a over a, which is 2. Theta equal tan inverse 2. That is 63.4. So this angle is 63.4. RB. The resultant force of F1 and F2 is R. So F R equal F1 plus F2 resultant force. 3i minus 2j plus ai plus 2aj. So R equal 3 plus ai plus minus 2 plus 2aj. So given that this R is parallel to 39 plus 10j, so this is R. So this one 3 plus ai plus minus 2 plus 2aj. So now this R is parallel to another vector, that is 39 plus 14j. Sorry, 10j. Now you can remember from vectors, I believe, if this is A, we are writing parallel one is lambda times A. So if this is B, we can write this is mu times B with the constant. Mu is a scalar. So likewise, I can write this one. This is equal lambda times this one. 3 plus A I plus minus 2 plus 2aj is lambda times this one. 13i plus 10j. So this is going to be 13 lambda I expand this one, 10 lambda j. So 3 plus ai plus minus 2 plus 2aj. Now when we consider the I component, 3 plus a equal 13, and the j component minus 2 plus 2a equal 10. Sorry, 13 lambda. So this is 10 lambda. So from here, I can write 3 plus a divided by 13 is lambda. I'll cross multiply. This is minus 2 plus 2a divided by 10 is lambda. So this is also lambda. This is also lambda. Because of that, those two are equal. Hence, 3 plus a over 13 equal minus 2 plus 2a over 10. Now let's cross multiply. 10 times 3 plus a equal 13 times minus 2 plus 2a. So this is 30 plus 30, 10a equal minus 26 times minus 4a. So this is going to be 14a equal, I think this is wrong, minus this value is wrong. This is going to be 13 times 2 is 26a. So then 30 plus 26 equal 26a minus 10a. So this is going to be 16a equal 56. So then a equal 56 divided by 16. So a equal 3.5. The second method is for that is 3i minus 2j 3 plus AI plus minus 2 plus 2AJ. Let's say this is theta, so this is R. This is parallel to 13I plus 10J. So this is also theta because they are parallel. So x-axis, let's say theta. So tan theta equal minus 2 plus 2a divided by 3 plus a. And again tan theta equal from here 10 divided by 13. So this has to be equal 1 equal to, so minus 2 plus 2a times 3 plus a equal 10 over 13. So 13 times minus 2 plus 2a equal 10 times 3 plus a. Then also you can work out a value. Question number 10. F1, F2, F3 acting on a particle is it is in equilibrium. R equal F1 plus F2 plus F3. So R equal minus 7 and 4 plus F2 4 2 and plus AB which is minus 7 plus 4 plus A 4 plus 2 plus B. So this is minus 3 plus A, this is 6 plus B. So this is R, this is R. Now R equals 0 as P is in equi. So hence minus 3 plus 6 plus B equals 0 and 0. So this will be minus 3 plus A equals 0 and A equal 3 and 6 plus B equals 0, B equal minus 6. That's a correction. This is minus 4, then minus 4 plus this is minus 4, minus 4 plus 2 minus 2, then this is minus 2, then minus 2 plus B equals 0, B equal 2. Part B, now F1 is removed. Now remaining F2 and F3 we found out A and B now. We need to find R, the resultant force. R equal 4y plus 2j, R equal F2 plus F3, 3i plus 2j. So R equal 4 plus 3, R equal 4 plus 3i plus 2 plus 2j. So this is going to be R equal 7i plus 4j. So magnitude of R is now 7 square 4 square square root, that is 4916 square root, that is square root 65, and the magnitude is going to be tan theta equal 7 over 4 over 7. So theta equal tan inverse 4 over 7, that is 29.7 to 2SF. So theta angle is this. So this is 7i plus 4j.